Very happy to be here at this conference because ESSA, that means the European Social Simulation Association, and the community behind it is very important for this European flagship project. We also have an official letter of support for this project. So what is FuturICT about? There is a European FET flagship call at the moment, and the European Union wants to give 1 billion euros actually for 2 flagship projects. They want to have a real big visionary project, a kind of man on the moon kind of vision. And so that is very challenging. In fact, there were 21 projects applying for this program, and 6 of them were selected as flagship pilots, among them FuturICT, which came up first. FuturICT is the only project focusing on socio-economic challenges. It wants to provide science and technology to manage a complex, connected world. While the other projects are on material science, like graphene could be a future material for computer chips. Guardian Angels is about lower energy sensors. The Human Brain Project wants to build a brain in silicio. Future of Medicine wants to come up with individualized medicine. And then Robot Companions wants to provide help by robots. So you can see FuturICT is the pilot that comes closest to what I think most of you are interested in. And what is the motivation of this project? Well, our world has changed. We can feel that, but it's hard to say what exactly has changed. For sure, there is globalization and technological change. And these have created a strongly coupled world. That means today we have global exchange of people, money, goods, information, and ideas. And while the world still looks the same because the components are more or less the same, the interactions have changed dramatically, and that has serious implications, as I want to point out later on. We think that actually a number of problems have been aggravated by the circumstances of stronger networking and interdependency, and that new problems have come up. And here's a list of some of the problems that we are concerned about recently. And one of the main messages to start with is that network infrastructures not only create new functionalities and services, but also pathways for disaster spreading. In fact, the situation is quite serious because there have been 3 mega events which may actually lead to a global shift in power. So, altogether, the financial crisis, the Arab Spring, and also the Japanese earthquake and nuclear disaster may shift the power from one area in the world to another area, and we don't know exactly what will be the outcome of this. Now the question is, what is characteristic of strongly connected systems? So far, still a little bit a claim, a hypothesis, that our world has fundamentally changed. But let's assume we would have strongly connected systems. What would be the implications? First of all, we would expect a faster dynamics. Second of all, an increased frequency of extreme events, and those events could have almost any size. We would expect self-organization and strong correlations to dominate the system dynamics. We would expect unwanted feedback cascade and side effects, counterintuitive behavior, predictability should go down, system optimization should be impossible in real time, even with supercomputers, and possibilities of external control should be limited, according to this hypothesis. That also would imply a larger vulnerability to random failures and external shocks, and old recipes should not work anymore. As a consequence of that, we would expect a loss of trust. Now, very unfortunately, our current world shows all these features. And many of the problems we are facing result from a wrong perspective, which often is still component-oriented rather than interaction-oriented. And that's why we need the science of complex systems, because that's the science which is focusing on the effect of interactions. To give us a better imagination of what strongly coupled systems are about, I was looking for an example, and nuclear forces are an example where we have strongly coupled systems. So, what are the implications of that? Here is an illustration of chain reactions as they occur actually also in nuclear systems under certain circumstances. And the characteristic feature is that a small perturbation actually can have an impact on the whole system. So this is an illustration. These table tennis balls are located on mouse traps, and you've seen that a single ball can actually mess up the whole system. And that is quite typical of many cascading effects that we're seeing, cascading effects that are at the origin of many disasters. Also, political regime shifts, financial crisis, and so on and so on. So I could give you many examples where we can find cascading effects in social systems and how they lead to serious problems. We also know that these kinds of strongly coupled systems are hard to control. You've seen it last time in Fukushima. So the question that results from this is, have humans inadvertently built a global time bomb? When I first asked myself this question, I was kind of shocked. I didn't dare even to think about it. I was not sure about it. And then I was looking for other people's opinions, and I found this. Warren Buffett, one of the richest men on earth, warns of an investment time bomb. And he was saying derivatives are financial weapons of mass destruction. And he was continuing, the rapidly growing trade in derivatives poses a mega catastrophic risk for the economy. And this is what he stated in March 2003 already. So this is shocking and somehow backs up the conclusion that I've shown you before. It means we need to be daring in our thinking about these systems, otherwise we won't understand the risks. And there's some other problems coming up because technological change is going on. We're connecting billions of components in information and communication systems. And more these systems actually are becoming artificial social systems. It means those components are taking autonomous decisions, and they may have an internal representation of the outside world and expectations regarding the future, which is the basis of their decisions. So that is kind of typical features of social systems. And actually, one example is the computer-based automated trading that is now being performed at stock markets most of the time, actually. So we have these systems already around. We have seen that that can actually have catastrophic impacts. So we need to be aware of this, the risks, and we need to understand those socially interactive systems in order to make sure they're not doing the wrong thing. Because most of these information communication technology systems are not designed and tested for the collective behavior that results from the interaction of their components. And as a result of that, we may have all the problems that we know from social systems, like a lack of coordination, instabilities, an inefficient use of resources, I mean, tragedy of the commons, in other words, conflicts of interest, cybercrime, cyber war. These are the results. And networking actually itself can destabilize the system depending on the kinds of interaction in the system. I think most politicians and business leaders are not aware of this fact that as you go on connecting the system, it could inadvertently again destabilize the system from within. Without an external threat, it would just fall apart in some sense. So we need to raise awareness of all these kind of things, and for sure we need to have an understanding of social systems in order to create ICT systems in the right way. We are so dependent these days on ICT systems that we cannot afford that they would destabilize or fail. So there are a number of really big challenges out there that we need to worry about, that we need to address in the 21st century. And here is a very nice quote of Lee C. Pollinger, president of Columbia University, said the forces affecting societies around the world are powerful and novel. The spread of global market systems are reshaping our world, raising profound questions, and these questions call for the kinds of analysis and understandings that academic institutions are uniquely capable of providing. Too many policy failures, he thinks, are fundamentally failures of knowledge. And I would think so as well. So there are huge knowledge gaps out there, and we need to fill them by creating what I call a knowledge accelerator. And how to do that? Basically, we need to bring together the knowledge of different fields, of the social sciences, natural sciences, engineering sciences, in order to make sure that we catch up with the course of events, with the rate at which new problems are coming up, and actually we would like to be one step faster at least in order to avoid disasters happening in the first place, or at least be able to mitigate them. And for that we want to integrate the areas of information communication technology, which is the area where this flagship call came up, where the money comes from, with the social sciences and with complexity science, with a number of goals. First of all, to create a scientific outcome which would be the ability to understand our global techno-socioeconomic system, and the technological outcome, which is new ICT platforms for collective awareness and participation. I'll come back to this later on. And finally, a societal outcome, which is the ability to manage our global system towards a more resilient and sustainable society. And this comes with a number of overarching research challenges, and many particular research challenges as well, but these are kind of the subject that seem to be relevant for all the three areas that we want to integrate. I mean, study of the interrelationship between structure, dynamics, and function, strongly coupled systems, interdependent networks, contagion and cascading effects, ecological and social systems thinking, managing complexity, incentives, integrative systems design, resilience and systemic risk, sustainability, and trust. Probably you could come up with many more, but solving these problems, I think, will keep us busy for some time. Us means all these 700 supporters we have by now, and others who may join in the future. And I actually expect it will have a new era of the social sciences. We now can do many more experiments in the lab and even in the web. There are big data out there about people's behaviors, and we can do computer simulations on large scales. And all of this generates many new insights. In particular, it will be powerful to combine these different kinds of approaches. And so today, models considering spatial and network interactions, heterogeneity, randomness, and we'll come back to this later on in the second part of my talk. Models of emergence of social cooperation, also that will be part of my later talk, or formation of social norms, spreading of conflict and violence, collective behavior, emotions may also be simulated in computers up to a certain extent, of course. And then conditions for other regarding behavior, learning and communication and cognitive complexity. In principle, these things, as you well know, can, to different degrees of realism, be implemented in computer models and artificial society models. And it's not only fundamentally important and interesting, it also has a practical relevance, actually. So there are new strategies to reduce crime and conflict that may be derived from those findings. New recipes to overcome tragedies of the commons. Prediction markets have been created. New methods to avoid crowd disasters. Congestion avoidance systems, smarter cities. There are new recipes to make stock markets more robust. It's more a political problem to implement those. And new approaches to make production more efficient and stable, and so on and so on. So there are a lot of things actually that are of practical importance, and so as science progresses, that also creates a lot of new applications and potential spin-offs and business opportunities in jobs. It's very important to tell politicians, because if you tell it to them and in a convincing way, they will put more money into our scientific field. And all of this is fueled by data, I would say. Data that are now becoming available on a much larger scale. Here are just two examples of applications, actually, that I've been working in. It's indicated that I've been doing some traffic science before. And here is a new decentralized self-control principle of traffic lights that was inspired actually by self-organization of pedestrian crowds that show often oscillatory flows at bottlenecks. And so the idea was that we could interpret an intersection also as a bottleneck, but for more than two flows. And we could transfer this self-organization principle to create kind of emergent oscillations. So in that case, the flows themselves would kind of control the traffic lights. Would be a bottom-up approach based on local interactions, short-term anticipation, because we are measuring the inflows into the road section, not only the outflows. And based on this short-term anticipation, we can flexibly respond to the actual traffic situation. And it turns out that this approach is actually more successful than the classical optimization approaches that are basically following this rational agent approach, where we have a supercomputer, very expensive, trying to do its best to optimize the traffic lights in the city. But it's an NP-hard optimization problem, and for that reason it cannot be done in real time in an exact way. So you have to do approximations, and that is where kind of the previous control strategy fails. So my proposal is, for those strongly coupled systems which are hardly predictable in their dynamics, but still a little bit predictable for a short time, and with some randomness in it, for those systems it's much better to have a bottom-up self-control approach based on flexible adaptation. So there are new problems, but also new solutions. And as you can see, this approach benefits everybody: public transport, individualized traffic, pedestrians, cyclists, and the environment, actually. Here's another example where we have been successful. We have helped to reorganize the Hajj in 2007. In the years before, there were often serious crowd disasters, more than 200 people dying in many cases, and that was the typical situation before. So even emergency vehicles could hardly move forward. And based on this reorganization of the Hajj after more than 1,400 years, by the way, which was a quite difficult challenge with more than 200 factors that had to be considered: political, religious, financial, historical, and so on. We came up with a solution that made everybody happy, including the pilgrims, and so it became much more safe and orderly. And now other people have taken over the organization. But the principle was based on another flow organization. We were trying to avoid crossing flows and counter flows, but also there's a scheduling program, there's flow monitoring. That means, again, data are important, and there's an adaptive rerouting to respond to critical situations. When there is a high density on a certain road, then some of the flow would be diverted. So there are contingency plans. People don't wait anymore for a problem to come up. They have, for all kinds of conceivable problems, there are ready-made solutions that you just apply when a certain case comes up. So you have a backup solution or two. And that is, of course, important for other systems as well. Now, how is the whole project organized? A €1 billion project that is really so much bigger than anything we've done before. Apart from, actually, this project, there was also the new Jamara Bridge cost $1 billion. So it was pretty much the same order of magnitude. So how to organize that? And this is basically the structure of the different research activities. This is the area that probably you're most interested in, or that as well, maybe that. Let me explain a little bit those different focus areas. You can see over here that there is something that we call the Living Earth Simulator. It's trying to come up with artificial society models that are mimicking the activities on the real world as realistic as it can be done, also given the data that are now becoming available. And I want to make a distinction, actually, to a project that has been done in the past, which was, to my opinion, very important to raise public awareness for some problems the Earth may face. But as compared to this study, FuturICT is not aiming at long-term forecasts. It rather addresses current and generic problems, and the goal is the improvement in the system performance and the ability to absorb shocks. That means to increase resilience, in other words. We consider spatial and network interactions, heterogeneity, and randomness. We're using network theory, complex system theory, social science models, multi-agent simulations, multi-level models, experiments, participatory platforms, and so on. So many more different methods that are being used, and new methods of investigation are being created. We sometimes call them socioscopes. The Living Earth Simulator is just one of them, and the planetary nervous system is another one, and the global participatory platform a third one. And then finally, the interactive exploratories are an intermediate stage on the way to these Living Earth Simulator. then of course we should make use of the big data that are becoming available and the possibility to mine them in real time. And of course, one big difference is that FuturICT is supported by hundreds of scientists, while this was basically done by Meadows and his wife. People sometimes worry about predictability. And the first thing I want to say is that prediction, which is a statement under what conditions something is likely to happen, is not the same as forecasting. That means trying to say when something will be happening. We are much more interested in prediction. We're not making claims about forecasting. Forecasting of the exact timing, and I agree with many people in that, is usually difficult in social systems. But still, I would like to point out, likely courses of events can often be predicted because cascading effects follow basically from causal relationships. So if you look at the course that the financial and economic crisis has taken, this looks very plausible, the different steps of this crisis. So from that point of view, there is no surprise. In principle, we can analyze historical crises and disasters, and we've done that actually for a number of different disasters, also for earthquakes and for thunderstorms, forest fires, and so on and so on. And you find causal interrelationships that you can demonstrate in a network. You can say if there is a problem somewhere here, then that can have cascading effects towards where the arrows point. So there is a kind of possible sequencing. And we don't know exactly where this cascading effect will stop, but having this kind of picture helps you to anticipate the next problem. And rather than running behind the problems that are out there and coming too late always, it's better to know what might be the next problem. Invest your resources into preventing a further cascading. So this is what those kind of analysis can be good for. But I would like to point out that short-term anticipation, as it's being done in a weather forecast, for example, or also in this self-control system for urban traffic flow that I showed you, that is often enough to reach significant improvements through adaptive strategies. So we don't need to have a long-term anticipation in order to improve the situation. And that will be very important. We don't claim that we will get rid of all the problems of the world. We're just saying that if we can improve the situation, say by 1%, that would already ensure that our investments pay off multiple times. And actually, I am convinced that in many cases we can reach improvements of 10 to 30%. That is the experience that we collected in the past. So then there's this other discussion about the impact of forecasts on people's behaviors. And some people say, okay, there's this self-defeating prophecy effect, so basically it does not make any sense to model this because something else will happen. But we also know there is another effect which is just the opposite, the self-fulfilling prophecy. And there is a third case actually where people are not influenced significantly by prediction. And that very much depends on circumstances. So if we don't have the parameters that determine the outcome, then of course we cannot say what will happen. But more and more data are becoming available, so in principle we may get into a position that we can actually anticipate which of those cases will happen, and moreover, information feedback effects can be taken into account by adaptive recommender systems. We have done an experiment in the past where we have shown that this problem of the self-defeating prophecy can be overcome by such a system. All right, so I believe the Living Earth simulator can be useful, but it requires a lot of data, of course. And where to get those data? Those data will come from the planetary nervous system, as we call it. I will come back later why we have called it like this, but in principle that is to be imagined as a sensor network, where a sensor is anything that is collecting data. Could also be the internet. And we know the internet is full of data, so there's a rich source of data that might also be used to feed the Living Earth simulator with the data needed to make realistic simulations. And then there's this third new method and platform, which I'll come back to later. So how to establish a planetary nervous system? I mean, you must be aware we're talking about a 10 years project that will start in a few years, okay? The other thing we need to remember is, how did our world look like 10 years ago in the area of information communication technologies? We didn't have an iPhone. I'm not sure how many laptops we used. We certainly didn't have Facebook and all these kind of things. So these things just came up in the past, say, 3 to 5 years. So if we look back then, we see how much has changed in this area. And we can barely estimate what might happen in the next 10 years. But I think we're getting there. So in principle, the goal is to measure the state of the world in real time, and to get those data by real-time data mining, which is also called reality mining. And it could be done, for example, also by smartphones. Of course, smartphones, as you can see over here, have all sorts of sensors that can provide useful information. But of course, they shouldn't do it by themselves. They should do it if we want our mobile phone to collect this data for a system, and we want it to happen in a privacy-respecting way. But in principle, users are interested in services, so there are incentives that would make people share data with others. And so the issue is to find an incentive system, and in particular what is important, that the people who provide data voluntarily would also benefit from that, and would participate in the profits generated with the provided data. It requires also a micropayment system, and it's very important from my point of view that users have control over their own data and also of the use of their data. But there are two examples that give you an idea how that can be used. So OpenStreetMap was a project that was basically creating a map of the road network of the world in such a decentralized way, okay? Just based on data that users have provided using the GPS information. Then there also, it's possible to come up with earthquake sensing and warning, because there are accelerators in your mobile phone, and so if it starts to shake somehow, it can feel it, can have different origins, but if many mobile phones do this at the same time, then that's a sign it's an earthquake. And it's time to get out of your house, basically. I mean, maybe it's too late for you, but your friends who are living 200 kilometers away may still have enough seconds to get out of the house if there is an alert set off by your mobile phone. So you can see there are new kinds of applications that can save people's lives. But altogether, the question is, how can we promote sustainability? How can we protect the fabric, the basic of our society? And in many cases, I think this is being damaged or even exploited, as the environment has been exploited in the past and still is partly exploited. But one important point really to change this, to protect our social fabric, social capital, social networks, and so on, is to be able to measure it, to quantify it, to quantify the social footprint, basically, of our decisions and actions. And that can create collective self-awareness and would prevent us from doing some mistakes. That is the idea. So, having this planetary nervous system, now you understand better why we're talking about the nervous system, because our nervous system helps us to avoid mistakes by awareness of the situation. I'm coming to the interconnected exploratories, and there will be exploratories of society, economy, technology, and the environment. And these are basically institutions that collect a lot of data, mine those data, do computer simulations, and also have interactive elements to explore possible courses of events and possible futures. And here are a number of different areas that need to be taken into account in order really to get into a position to get a systemic view of our world. It means how these different components of our world are interacting with each other. So that requires to work across disciplines, of course. We need to overcome the silo thinking. But that is really a challenge, and how to do it? We're starting off still in a disciplinary way with observatories built around experts who have shown in the past that they can handle large data sets, visualize them, and interpret them in real time in many cases. And basically connect these different observatories over time, integrate them, and also scale them up and make sure that they're becoming more and more accurate over time in order to integrate them into exploratories and finally this FuturICT platform. And this platform also will have this participatory platform, which we want to be a transparent platform for everybody, an open platform. So we want to overcome the situation that we currently have, where we have kind of black holes for data and the data fragmentation that prevents really to get a better understanding of our problems. It will be very important to have this transparency in order to have the best possible quality of data, transparent algorithms. So in many cases, we don't know when we run a certain search request, what is going on there? How much manipulation is behind this? Now, we would like to see what is being done with the data. Also, we would like to have responsible use. Transparency, again, is a very important aspect to get there. And we want to create a new public good like our environment, air, and languages. At the moment, with our fragmented databases, we have a situation as if everybody would own a few words of our language. We could not talk to each other if that was the case. So data should be owned by humanity rather than by a company. I think it's not a good situation that some companies know more than a society when it comes to fighting a EHEC crisis or some other crisis. We were simulating the spreading of diseases where we didn't have the supply chain data to do that. People were dying because the data were not available. I think that's not acceptable. So we think this new platform that we want to create, that will also be a platform that fosters new services and jobs, that reduces barriers for social, economic, and political participation, and it will enable an age of creativity. But to get there, we have to overcome a number of problems. We need to find mechanisms to avoid data pollution, manipulation, misuse, and cybercrime. And for that, we need to have an information ecosystem that also builds in reputation mechanisms. I won't go into this in so much detail. I rather want to eventually conclude this part of the talk by saying FuturICT builds bridges between communities. And a federated big science approach is needed. Otherwise, we cannot catch up with the pace at which the world is changing and new challenges are coming up. We are pursuing an open platform approach. We imagine it like an international space station, allowing other countries to participate, like Japan, China, Singapore, Australia, South America, Africa, some continents among them, of course. And so basically, there will be a global effort to address global challenges. And the European Union will be happy to hear that I think Europe can actually lead this global endeavor, because Europe is very advanced in social simulation. And there are many other reasons for that as well. All the European academic powerhouses are involved in 5 supercomputing centers. Also, George Soros is excited about the JRC standing behind Joint Research Center, the OECD, and so on. We think it's actually a moral obligation to do what we can do to address the 21st century challenges. We must avoid that powerful tools and social innovations end up in the hands of a few stakeholders only. We want it to benefit humanity. Now, here's a quote by George Soros, and he says, FuturICT can, I believe, make a significant contribution to the understanding of the evolution and change in societies, meeting the formidable issues of governance, climate change, sustainable economic balance that we are all faced with in the coming decades. And here's just a few numbers that illustrate that really a small improvement would already pay off multiple times. So we can reduce losses by understanding those systems better, by mitigating these problems, but also there are new kinds of business opportunities, and Facebook maybe is a good example for a social-inspired platform that's now worth $60 to $80 billion. So there is a huge, huge potential. I'd also like to remind that Google, which is one of the other most valuable companies in the world, is based on the invention of social scientists, which was the PageRank algorithm. Right? There's a lot of power in our ideas, and we should make sure they're being used to the benefit of people. And so, FuturICT is aiming at filling knowledge gaps in a number of different areas. So we think a non-equilibrium economic theory needs to be developed. We need to have a theory of strongly coupled and interdependent systems. We need to have a theory of the behavior of multi-level complex systems, considering cognitive complexity. And we need a new data science. We need to understand systemic risk much better, and we need to get towards a better integrated risk management. But also, from a societal perspective, it's very important to come up with a number of innovations that are overdue, like create open data platforms, come up with technologies to do privacy-respecting data mining, come up with a trustable web and with ethical ICT. And with this, I'd like to conclude my talk about future ICT. I'll be available for your questions. Thank you very much.